Okay, so example 5 from chapter 4 deals with vectors, which we haven't talked about before. Um, this problem I've simplified how the vectors work. If you have a vector is basically like it's a segment, but it has a direction associated with it. So if I have a vector that has its tail at the origin and its head is at some point, that's not a ray, by the way, it doesn't go on forever, it ends at the end of the arrow. So if that point is at like, I don't know, let's say 4, 5, well then this vector is called 4 comma 5. It just means that in order to get from wherever its tail is to wherever its head is, you have to go 4 units in the x direction and 5 units up. That's it. That's all it means. So like if I had some vector floating around here, let's say that looks like this, and this length right here and this length right here, let's say this length is 3 and this length is 6. Well, then this vector right here, no matter where it starts and where it ends, that vector is to the right 6 and down 3. So it kind of tells you what your horizontal and vertical translations are. And that's it. That's all it really tells you. So, like, if you knew where this point started, and then you knew how much the vector, what the components of the vector were, you could tell me where it ends. Okay? And that's all that you really need to know. For now, though, we're always going to put vectors. When there's an O there, that implies that the tail's at the origin. So that makes problems a lot simpler to work with. So let me get rid of this. And let's do this problem. So we've got a vector OP, tail's at the origin, and P's at 6, 1. Okay, so tail is at the origin. P is at 6, 1. So that'd be about here. So here's P, here's O. P is at 6, 1. And the vector OP, you put a little arrow pointing in the direction that it goes. You always put the tail first and then the head second. So OP equals 6, 1, just to get the notation there. Which just means the point P is at 6, 1 right now, since the tail is at 0, 0. And then the vector gets rotated 100 degrees this direction. So it'll end up, I don't know, somewhere about here, let's say. Right. So let's say that this point is Q and the new vector is OQ. So we're trying to figure out OQ equals what, comma, what. And in order to figure that out, really we just need the coordinates of Q. Okay. And let's see, we rotated it, how many degrees? 100 degrees. All right. So we want to figure out where Q is. X, comma, Y. Right. Okay. So if I kind of rewrite this problem down here, so here's Q right there. Q equals XY. If I knew this angle, theta, then we know that X is the same as R cos theta and Y is the same as R sine theta. So you'd also need R, right? So we need XY is going to be R cos theta, R sine theta. You can kind of picture as we rotated it, there's this big circle around here, right? Well, theta is not 100, it's 100 plus whatever this angle is right there, right? That little angle. So I'll call that, I don't know, let's use another Greek letter. Let's call that alpha, okay? So in order to figure out what alpha is, well, I could make a little right triangle right here. This length is 6, this length right here is 1, and it's an acute angle. So I could say like tan of alpha equals opposite over adjacent, or y over x, so 1 over 6. So alpha is going to be tan inverse of 1 over 6. Remember, tan inverse helps us solve for angles. Okay, so tan inverse of 1 over 6 in degree mode ends up being pretty small angle, 9.4623 degrees. And so my theta down here is 100 plus that. So it's 100 plus 9.4623 degrees. So it's going to be 109.4623 degrees. So there's my theta. We also need the radius. Well, that's this right here. And I know that the radius is really going to be r squared equals 1 squared plus 6 squared. That's how I'm going to get it. So r squared equals 37. So since it's a radius, I'm only going to choose the positive square root, so root 37. Well, now I can figure out where Q is because I have the radius is root 37, and my angle is 109.4623 degrees, which you should probably store in your calculator, really. And so then this xy coordinate for Q at xy, is really going to be root 37 cosine of 109.4623, comma, root 37 sine, I'll put degrees here, sine of 109.4623 degrees. And making sure you're in degree mode, not radian mode. If you work this out, you get x is negative 2.027, and you get y is 5.735. And so then, since it says what's the vector OQ, this is just the location of Q, and we know that O is at 0, 0. So in order to get from O to Q, you go backwards 2.027 and up 5.735. So you would just write OQ equals, and then using the brackets for vector notation, it'd be this. Okay. I'll do the other examples in a separate video because I think this one is sort of a unique example.